So in this video I want to run through this workflow of creating this local coordinate system grid. And there's lots of different ways we can do this, but the most common way is that we sort of want to be able to do ourselves is if we receive data that's like this. If we get some sort of bit of data that's in a local mine grid and the same bit of data that's hopefully in a known grid, so it might be in Australia, we use Map Grid of Australia, and then we can get some coordinates from both of these, so coordinate pairs, and then we can create a custom coordinate system that we can then use to transform data between on the fly. And we can use this in GIS programs, and we can also use it in the CAD and all the other CAD products like Infraworks and other environments that support coordinate systems. So it flows through to the whole ecosystem. So let's say we've got this boundary, and this boundary was given to us for some sort of lease boundary, and we've received it in both the local coordinate system, so that's why there's no imagery here, and we've also received it in the known coordinate system, which is MGA Zone 56, 1994. So this boundary, now in CAD, we've often done this before in the past where we can draw a line between there, and draw a line between there and there. And so now you can see there's this big line between the local coordinate system and the known coordinate system. And all we can do in CAD, it's a bit dodgy and it's not always completely accurate, but it's usually a pretty good first pass for a lot of stuff, is we can use the align command. And I could, let's say that's the source point and that's the destination point. That's the source point and that's the destination point. And then we say scale objects, I say yes, and lo and behold, we've moved that object. There's two on top of each other there. But that's only really good in sort of manual instances. What we want to be able to do, and the reason we want to create a local coordinate system, is because we want things like imagery, like public imagery, to be visible in our local coordinate system. We want to maybe be able to create Infraworks projects in the local coordinate system, so we don't have to keep converting data. And maybe in our GIS products, like something like QGIS or ArcGIS, it would be nice to be able to see quickly transform data we receive into the local coordinate system and also view it alongside public data and other data that's in the main coordinate system. So although you can sort of do this sort of stuff, there's a lot of more benefits if we create a local coordinate system. So how are we going to do this? So firstly, we need some coordinate pairs. Now we can do that lots of different ways, but let's just use CAD because we're in the CAD environment. You do this in the GIS environment as well. But all I want to do is create 3 known coordinates and then transform them and get 3 pairs. Now I could get the corners of this property boundary if I wanted to, or I can just create some arbitrary points and use the align command. So let's say this is my site, this red mud dam thing here. I'm just going to place some points around this. So that can be point number 1, and this can be point number 2, and then maybe this can be point number 3. Now I'll just increase the scale so we can see that. Up to 1:2000, maybe higher. There we go. So you can see my 3 little points there. And what I want to do is get the coordinates from those points and put them into something like Excel. So bring up my tool space, and here's my points here. So I'll go select all them, copy to clipboard, and open up Excel. Now we'll put initially, these will be the MGA X coordinates and the MGA Y coordinates. And now we also need the local coordinates for these same pairs. So let's go and do a transform now. So if I actually do that align command, and I'm going to say, look, source, destination, source, destination, and scale objects, yes. And so now we can see those 3 points have been moved down to this location down here. And we can now do the same thing. Go in here, whoop, sort by point number, grab both of them, put them in here. And now these eastings and northings will be our local chords. So let's whack them there. So there's going to be a Z and a Z. And we'll say local X and local Y. Now we can delete this stuff so we don't accidentally get confused. 0, 0, 0, 0, 0, 0. Now, CAD always puts a little M after your stuff, so we'll just remove that now. Replace, done. And so now we've got our coordinate pairs. We know that point number 1's MGA X, Y is there, and its local X, Y is there. And we've got it for 3 different points. You can do as many points as you want. For when you don't have data that's exact, so if it doesn't move exactly on a line like this and perfectly match up, you may want to add more points to get a bit more accuracy, particularly if you're using something like Imagery to get those coordinate pairs. Sometimes you might just receive an Excel file with those coordinate pairs, and you can use that as well. That's perfectly acceptable. But you can have more than 3 points, and it will make it more accurate in some cases. So now, what do we do with these coordinate pairs? Well, there used to be a script you can use, but now in QGIS, there is a Geosciences plugin that we can install. So if you have QGIS 3.14 and later, you should be able to go to the plugins up the top there and just search for Geosciences here, Geoscience plugin. And it says here that it can create local grids. It's kind of a bit vague, really, but if we go into the Geosciences plugin there, we can see there's a create local CRS command here. And what this is doing is it's going to create us what's called a WKT coordinate definition, which is well-known text coordinate definition, that we can paste into both QGIS, ArcGIS, and CAD to create our own local coordinate system that we can use for transforming data on the fly. And all we have to do is we have to manually, unfortunately, paste these data sets in here, because you can't just copy paste the whole lot. You just sort of got to go one by one. Now, just be careful. The base coordinate system has to be the known coordinate system. So actually, we should better set this now. I know it's MGA 94 zone 56. So these are the known coordinate systems, which is usually the big coordinates. And the local one is usually the small coordinates. So don't get that the wrong way around, or otherwise you'll get a transformation that's probably back to front. And we don't want it back to front transformations. Okay. Bit annoying, but almost done. Okay, done. So now we can put a name for this grid. Now, local grid. Maybe it has a name. I'm going to call this RMD local grid. We've picked our coordinate system. We've got our pairs in. We should now be able to hit calculate. Now, what it's going to generate is this WKT string, and all this information here, we will go through this to create the K coordinate system in a sec, but it's going to create an affine parametric transformation, which is like a 7-point transformation, I think, that has these parameters, these A0, A1, A2, B2 parameters that we can use to transform between the local grid and the known grid. So if I copy this, Control C or copy or whatever, and firstly we'll test this in QGIS and go up to settings in QGIS and go to custom projections. I'm going to hit the plus button here to create a new one, and I'll give it its name, RMD local grid. Sure. And the format we want is the WKT, and we can hit paste on the string there. And then we want to hit validate just to make sure that we've pasted correct. And QGIS says, yes, it's good to go. And now we can hit OK. Now to test this, what we want to do is drag in that data that's in the local coordinate system and check that it lines up. So firstly, we can bring in the MGA one. So just bring in that DXF thing. Now, when you bring in stuff into QGIS, it has a little question mark. It's telling you that there's no coordinate system assigned. You can just click that, and I can say, well, that one is in 56. And then if we bring in the other one, the local one, and we can say, well, that one, and then now we can do a search for our coordinate system, RMD, local grid. This will probably be the one I created earlier when I was preparing this video. So now that's in our local grid, and we can zoom to layer on the local grid. Now, if we've done everything right, they should just be overlapping each other, and they are. So we know the transformation is working correctly between those coordinate grids. But more importantly, we should be able to change this, our project coordinates, to RMD local grid as well, which you can see that there's a rotation happens. If we look in CAD, actually, that is, I'm pretty sure what happens. Yeah, you see it gets rotated to the left when it gets transformed to local. And we should be able to bring in imagery and see that it's the same. So, I mean, you can bring in an XYZ tiles thing here to get Esri satellite imagery. There is a if you don't have imagery in QGIS, you can go install this Quick Map Services plugin. Initially, you won't see all this imagery here, but if you go to settings, you can go into the More Services tab here and hit the Get Contributed Pack, and that will give you all these other services you can see here. The one we want to use is Esri satellite imagery. So that's cool, and we can see that thing is cutting across the corner nicely, and it's transforming our imagery in the background there nicely. If we switch back to MGA Zone 56, still looks the same. So that transformation is working pretty good from what I can tell. I can't really attest to how accurate that is. I'm no coordinate system maths expert at all, but this seems to be working for a lot of my projects already. So, you know, do be wary. Make sure you check your data after you transform it, that it's actually transforming correctly. So this is good, where we can do this in QGIS, but what about the CAD ecosystem? Would be nice to also be able to do this in CAD, and we can actually do this in CAD. It's not quite as simple as a copy paste, but it's very close to. So let's go over to CAD now. And we now want to add a coordinate system definition in CAD. Now, this capability has been in CAD for a long time, actually, using the AutoCAD map tools. And the tool we want to use is the map CS create. And if we say, I want to create a coordinate system, and it's going to show up with the wizard up here. So I'm going to say start with a coordinate system. Yes. And you want to start with your known coordinate system. Now, my known system is create a new coordinate system from an existing coordinate system. And my known coordinate system is MGA 56. So I can hit assign on that. Give that a second to grab the coordinate system definition from that. Okay, done. And my new name will be RMD, local grid. And maybe I could put a little blurb here. Manually created transformation from MGA 94, zone 56 to RMD grid. And, you know, my name, sure. And then it is good if you choose a category to put this in here. I'm going to leave mine in the Australia category. That works for me. And it is referenced back to the GDA 94 datum, so I can leave that as well. Now, the hard part is we now want to get those same parameters from that kooky bit of text we were looking at before, which we'll bring up here. Custom projections, and in this RMD local grid. Let's go grab that. and we'll fire up Notepad, sure, and put that there, and then maybe we'll put that there, and we'll put CAD. Right, you CAD, you're hiding from me. CAD back here. Now what we want to do is we want to use a transverse Masada with a fine post-processor. And it'll say something about you'll lose your projection parameters, that's fine. But the reason we want to use this is this will give us the ability to add in these A0, A1, A2, B0, B1, B2 coefficients that we can use to do our transformation, and all it requires is us being able to sort of read this kooky bit of text, and we will soon find out it's actually quite simple. So the central meridian is stored next to this longitude of natural origin. It's typically 153 in Australia. We then want to grab those these coefficients. So down here we can actually see an affine, the method that it's using to do the conversion here, and we want to get these values here. So this is parameter A0. We want to grab that A0 one. That can go in there. Then we want the A1 one, which is here. Can go into there. Then we've got the A2 one, and we can go into there. Make sure you grab the little negative value. B01, go to there, and then the B1 can go to there, and then the B2 lastly can go to there. And then the last thing is to recheck the scale reduction, easting, northing. It should be set from the known coordinate system. So we can see the false easting here and the false northing are the same. And the scale reduction is here. Scale factor at natural origin, 0.9996, which is also in here, which is correct. And the origin latitude is also set to 0 here. Latitude of natural origin is 0. So that's perfectly fine. So if we hit next on that, we shouldn't really need to set that this should be held from the MGA coordinate system that we originally defined them, which is just the useful range. So anything that's outside MGA zone 56, it can report and say, hey, we probably don't want to use that bit of data because it's miles away and it won't work. It's then going to give us a little summary saying, is this all correct? You could go double check that and make sure it's right. I'm pretty confident, so I'm just going to hit finish. Okay, so now that we've created that local coordinate system, let's see if this works. So we should be able to go to Maps, CS Assign, and we go to RMD Local Grid. There we go. And now this is a bit of a bug in CAD. What you might need to do is just go to the geolocation tab and just remove the location data first. I think it freaks out a little bit when you try to do those affine coordinates. So I've removed location and I'll just reassign RMD local grid. And then we can say aerial. There we go, perfect. So that's the local grid, and actually it only does it in one view too. Let's just change to single view. It doesn't like that. There we go, done. So that's our data in local grid, and we can see it's cutting across that corner nicely, lining up with the imagery the same way it was in QGIS. Let's switch back to RMD local grid. Agree to the transformation. It's just letting you know that's the transformation it needs to do. Different imagery in QGIS, but nonetheless, same. I think this is using the Bing image. So that's cool. So now in CAD, we can get imagery to come in from public data and be transformed nicely as well. Now, what's even better is this. Once you add a coordinate system in CAD, a lot of people aren't familiar with it, it'll also transform to other products that depend on it. And one of the key products in in Autodesk Suite is Infraworks. So now if we go into Infraworks, and let's say we go to the model builder, and we go to start a new project, we could go to roughly wherever your project is, and in the coordinate system here, we can actually pick a coordinate system. And if we look in here, RMD, here he is, RMD datum. There it is. And I can hit OK. And now this local coordinate system can be used to create the model. And what's really great about that is now when you add stuff from Infraworks in the local coordinate system, Infraworks can automatically work out how to transform it. So quite often local grids like that can cause you a lot of pain. And this little workflow can really help you manage data that's particularly older sites that have lots of historic data in local coordinate system. But to these days, people are still using local coordinate systems, usually due to some sort of software limitation with some sort of mining software or something like that. And this little workflow can get you out of trouble. Enjoy.